Morning. Today we're going to work with logarithmic equations. And I know that some of you had voiced your opinion of not liking logarithms very much, but they really aren't bad. Just remember, a logarithm is a fancy word for an exponent. So on page 480, let's just look at this. If I have 10 to the 2 times 10 to the 3, they have same bases. So we would add the exponents because these are being multiplied. So that's the same as 10 to the 5th. So if I have the log of base 10 of 5 plus the log base 10 of 7, it's the same thing. These arguments are being added, which means, remember, these are exponents. If the exponents were being added, it means that the numbers were being multiplied. So this is the same thing as saying log base 10 of 5 times 7. All right? If we have log base 8 of x plus 2 plus log base 8 of 3, that's the same. See, these are the same bases, right? Log base 8. So we'd write log base 8. And these exponents were being added, so these are what are called arguments. The arguments are actually being multiplied. Okay, now what about division? If we have 10 to the 5th over 10 to the 3rd, what do we do here? To divide, we subtract the exponents, correct? So this would be 10 to the 2nd. So if I have something that says log whatever base minus log that same base of another number. Okay, it's the same as log base 3, but this time the arguments are being subtracted. So that means that the numbers themselves were what? They were divided. So this would be 14 over 9. And then there's one other property. What if I had 10 to the 5th and it's raised to the 3rd power? Now what do I do? Yeah, now I multiply the exponent, so that would be 10 to the 15th. 10 to the 2nd is 100, right? Okay, so now let's look at this. If I have 4 times the log base 10 of 100, this 4 is actually an exponent on here because it's being multiplied times the logarithm. So it's the same thing as saying log base 10 of 100 raised to the 4th power. Okay, and then lastly, if I have x times the log base 10 of 100, then that would be the same thing as log base 10 of 100. X is multiplied, so it's an exponent. So log base 10 of 100 to the x. Okay, so why did I go through and tell all of you that? Let's look at 118.1. It says solve. Log base 3, x plus 7, plus log base 3 of 2 equals log base 3 of 20. All right, so now what we're going to do here applies because every one of these is a log base 3. If they didn't have the same log bases, we wouldn't be able to do this. But this right here is log base 3. Remember, if these are added, it meant they're being multiplied. So this would be 2 times x plus 7. Okay, now at this point in time, I have a log base 3 equal to a log base 3. I have one log base 3 on this side and one log base 3 on this side. That means they're going to cancel out. I cannot cancel them until I get them to this point where it's a log base 3 equal to a log base 3, okay? Do not cancel logarithms when you begin, all right? They don't always cancel. This cancels because it's a log equal to a log. So now all I have left is 2x plus 14 is equal to 20. If I subtract 14 from both sides, I get 2x is equal to 6, x is equal to 3. Now, we do have to go back and check to make sure of one thing. We cannot take the logarithm of a negative number. So we have to plug this 3 back in up here for x and make sure that it's not asking us to take the log of a negative number. 3 plus 7 is 10, that's positive, so we're good, all right? If it had have given us a negative number, what we would have done was we would have crossed out x equals 3 and written no solution. Always check to make sure it's not asking you to take the log of a negative number. All right, next. This is log base 14 of x plus 3 minus log base 14 of x minus 3 equals log base 14 of 7. Sorry, I ran out of room there. Okay, well this time the logarithms are being subtracted. So if the exponents are subtracted, what does that tell us we were doing? Dividing. Okay, so we rewrite it as log base 14 of x plus 3 over x minus 3 is equal to log base 14 of 7. Once again, I have a log base 14 equal to a log base 14, so what do you think is going to happen? The logarithms are equal, so they cancel out. All right, so we have x plus 3 over x minus 3 is equal to 7, and I'm just going to write that as 7 over 1 because you can probably guess the way we're going to solve this is to cross multiply. So I'm going to put parentheses around these so we remember to distribute. 7 times this is 7x minus 21, and of course 1 times that is just x plus 3. And now we solve for x. So minus x, add 21, and divide both sides by 6. So x is equal to 4. Now do I just circle my answer and go? No, we need to make sure we're not taking the logarithm of a negative number or 0. So 4 plus 3 is positive 7, that's good. 4 minus 3 is positive 1, that's good, we're okay. That's the only places we had to plug in for x. All right, so see, logarithms are not as bad as what everybody cracks them up to be. They're really not bad at all. All right, one more. This is on page 481. This one has 3 times the logarithm. What does that mean? What does it mean when a number is multiplied times a logarithm? Or a variable, anything multiplied times a logarithm? Means that the number out in front is actually an exponent here. It's being raised to a power because when we multiply exponents, we're raising to a power. So this actually becomes log base b of x cubed is equal to log base b of 64. So we have a log base b equal to a log base b. Guess what? Same logarithms, they cancel out. So we have x cubed equals 64, so what is x? The cube root of 64 is 4. And the only place we have an x to plug into is right here, so it's not asking us to take the log of a negative number. So x equals 4 is the solution. Okay, we're going to have one other lesson, I believe, that's going to deal with logarithms. It's going to be with powers of the hydrogen atom and that kind of thing, that if any of you are in chemistry, you probably have dealt with. So we'll get to use logarithms for that kind of a lesson as well. All right, you guys.